I'm going to do a little walkthrough on some basic genetics and Punnett squares. This worksheet here is designed to introduce you to the ideas of homozygous and heterozygous and how those would end up predicting certain offspring in Punnett squares. So in this first piece, we're supposed to determine if these genotypes are homozygous or heterozygous. Heterozygous means that you have two different types of alleles. So for example, this would be a heterozygous genotype, and this would be a heterozygous genotype, as would this, etc. Homozygous is when two alleles are the same. And for abbreviation, we'll write HO. So this homozygous dominant genotype would be an example, as would this, as well as these two with both recessive alleles. We call homozygous dominant or homozygous recessive genotypes purebred. So for example, this is an example of a purebred, as is this. And there are more in that list. Hybrids are your heterozygotes. So that would be, for example, that genotype, as well as this one here. Then moving on, you are introduced to how the genotype connects to the phenotype. And here, you're given different genotypes, and you're asked to determine what genotype or what phenotype would go with each one. You're told that yellow body color is dominant to blue, and in that case, anytime there's a dominant allele, then that would mask the expression of the recessive allele. So for example, this would be yellow, as would this. However, the last genotype of two little y's would give us the recessive phenotype, which is blue. And then the same thing here, where it says square shape is dominant to round. Anytime you have the capital letter, then that is the genotype that would be dominant, and so the phenotype would show up as the such. And in this case, round would be last. Using this particular gene of body shape for SpongeBob SquarePants, we'll use that to do this Punnett square down at the bottom. You are told that SpongeBob met Susie Round Pants at a dance, and he is heterozygous for his square shape. Now that means that his genotype is big S, little s. Now Susie is round, and then according to what we wrote up here, the only way you can be round is to have both recessive alleles. So those are the genotypes of the parents, and we're supposed to figure out what are the possibilities of their children to have round pants or square pants. So first we separate their genotype into gametes, what types of gametes that they can produce. Remember, gametes are haploid, and so each sperm would have either a big S or a little s, and then each of Susie's eggs could only contain a little s because that's her genotype. And so here's how we would set up that Punnett square. And then we recombine the alleles to make the zygote. So remember, these are the gametes. And we'll say Bob. And then these are Susie's gametes. And then in here, these are the possible genotypes of their offspring. It doesn't mean they're going to have kids with all of these genotypes, but it's possible. And so they're possible genotypes and phenotypes. So we have two that have the heterozygous genotype, which, as we denoted earlier, would give them square phenotype. And there's also a 50% chance that they would be round. So, speaking of percentages, for square shape, there's a 2 out of 4 chance, or 50% chance, that they would be square, and the same for round. So hopefully that helps you get started on the rest of the worksheet.